Hey everyone, it's Joe Glines here in Dallas, Texas.
Yeah, and Jackie here from Copenhagen.
I don't know why I always say where I am. Like it doesn't matter, right?
But again, what are we gonna say? I'm Jackie, called whatever from the forum, right?
That's funny. Yeah, good point. So today's short talk, we were. I had a call this morning. Well, let me back up a little step. I was doing some automation for a company. It turns out they actually have a whole team of people at their company that also do automation. And it was a really good meeting. But they mentioned they use a tool called UI Verify, and so after the meeting, I wrote one of the guys and said, hey, could you guys give me an intro into this UI Verify thing? I'd like to learn more. And so they agreed to. And this morning, they gave me a good 30-minute overview of the tool itself and then how they execute it. And I got really excited. I think it's got a lot of potential for us. One of the things being, and Jackie was bringing it up earlier, was there was a tool built by a couple tools. One was built by Jethro, and then another guy had done some stuff with the UI automation in AutoHotkey, but we don't have any great tools for like the ACC viewer for looking at where things are and getting the path and then having a library to access and do stuff. Having said that, we were going to right now just dig into the screen reader tool that I had mentioned, which uses that UI automation connection, for lack of a better term. And Jackie was just going to kind of give me some tips on what's going on here. And that's where we are. So don't expect to like have a straight walk away of this is how you do something. We're just kind of kicking around and learning with this.
Yeah, I'd say, can I? Oh, I don't know if I can still not control that program, Joe. No, I alleviated it just a moment ago.
All right. There you go.
Yeah, thank you. I need to maybe... Did you still have it open?
Oh, I closed. I'll restart. Hold on one second.
Yeah, I probably can't control it anyway, but if I could.
Oh, that's right. Yeah. And I'm not launching it as an administrator, which is interesting.
Maybe it's doing it by itself.
Well, I turned off. It had it had something up, so I turned off the this hover mode use, but I'll turn it back on. Anyway, so that's that program. Let's see if you can control it.
Can't. Still can't.
Okay.
But could you maybe point at a ribbon button in Word?
Sure. Backward. So here, and now if I hit the control key, it should jump to it, give us a path.
It's showing it and all that, and it's telling us it's button bullet, I think it says, in the tree. And if you did a test on it, like evoke one of the patterns on it, we would also be able to see the test results here, right?
Right.
If you run the one that we're reviewing in a moment, the UIA grab text reader, screen reader thing, can you try and run that?
Sure. Let's close this in here real quick. Okay. And then you wanted to run it?
Yeah, just run it and then go to Word for the same button and try and click, was it tab?
Yeah, I think it's, I saw a message box here. I just don't see where it is.
You get it's somewhere.
Yeah.
But isn't it still on top, that virtual UI?
Oh, there it is. Bullets. Yeah. Look at that.
So it's grabbing the name, right? The same thing as this one is telling us.
Uh-huh.
So we're close, right? But what we might do is go to the screen reader, the one, and look at the code for that one, which is the one you have.
Okay.
You can go to the top of this code and maybe remove that. Can you remove that?
That was why I closed it. Yeah.
You're welcome to close it again because currently we're not going to use it. Yeah. Okay. So I have forgotten what the guy who wrote this
Nepter.
called. What?
Yeah, I see it right here, nepter.
Nepter. Yeah, that was what it was called. I think he was the admin of the Chinese AutoHotkey forum or something like that.
Yeah.
Oh, yeah, it says it right there, which is great. He made this. Nice. And what I wanted to see was what had he actually done? Could we learn something from this? And the first line that I kind of hit on here is the 22, the one with the com object create here, where he's apparently figured out what registry entries for these interfaces or program IDs to get the UIA com object. Nice. It's fairly advanced stuff, that's for sure. It's to the point of where I'll end up not knowing enough to keep explaining it. But for now, we have a UIA com object here.
Yep.
And then for the next few lines here, he's building that small GUI that we saw that returned it. And then he has this main function, the one that's actually called when you click on caps lock. You get to this main one. And what it's doing is it's grabbing the coordinates of your mouse. So because you had your mouse over that ribbon button, it's using the coordinates of that in this one function here, get element item. And then he's doing some stuff with that item and stuff like that. But currently what we will do is we'll jump. Oh, I can't use keyboard shortcuts through desktop.
I think that's a Zoom. I think Zoom changed some of their stuff. I've written them.
That's fair enough. But okay, we'll just look at a few of these, but we'll go to this one, the one that's called get element item from X and from Y. And he immediately sets the UIA variable to global. So the one he created earlier at the top,
Sorry, I'm just curious. Why wouldn't you just make it global at the very beginning and be done with it?
It's a matter of style.
Okay, all right.
Right. So yeah, you could have done that. You could also have passed it in as a parameter, so that way you would have kept the function thread safe or whatever you call that. And this is just the way he did it.
Okay.
Probably easier or whatever. Then you have him making an item, and then you have this del call. And here he's using UI automation element from point. Fair enough. The first thing he does is here on this VT. I know this is a virtual table. He has a function somewhere in here, right here, virtual table, shortened down, using numget with the size of pointers, just like the tutorial we saw the other day on bits, using that information to go programmably to the right place in a data structure. So that's what this VT is doing.
All right.
So let's go back up here. So from element from object, so he's using the UIA com object as the base, and then knowing that 7 places down, so 7 pointer counts down from that, you actually have this function, the definition of this function. So again, it's pretty advanced, but still, that's what this is doing. It's telling this del call to go to a specific place in a data structure to call this. This
he was nice enough to tell us here what he's connecting to, but that's the function he's going to use from,
Yeah, exactly. So he uses UI automation. He jumps to the 7th pointer place where this is placed.
Yep.
Okay. And then he passes it the com object. That's the first. That's the this parameter. If people have learned what the this parameter is in an object, and then he passes it an Intel 64-bit number. And here you can see he's actually pointing, passing it the point.
Yeah. The coordinates.
Yeah, exactly. So he's passing the x coordinate, and as we saw the other day, he's passing the y coordinate, but he's shifting it 32 places, right? So again, it's a 64 one. So the first 32-bit places are for the x, and the next 32, he's moving the pointer 32, and then he's placing the y there. Because again, it's a point structure. So he's doing bit stuff. And then here at the end, he's getting an element returned. He's getting a pointer, a data pointer, where in memory will it return this. So this one will have a number in it. So element now has pointer.
Yeah, and if not, it'll stop.
Yeah, that's this. So if element is blank, something up here didn't work. That's a good way of saying it, because then this would have been returned blank. It's a good, quick way of determining that. Mm-hmm. And then element is now the new thing, because this is this function. And then using the exact same method of using the virtual table on the element, and then jumping 23 places in this function, there's the current name method, so to speak. So he's going from this place to that place via that, passing it the element as the this, and then getting the pointer to the name, the current name, right? That's returned there.
To store it there, in name. Okay.
Yeah, so he now has information about where in memory is this function located if I want to call it. So, and then he continues on to collect more of these. You can see he's getting current property value, L name and L value. Mm-hmm. Again, he's moving along. He's calling the same place. He's calling this get current property value, which we saw on the other one. It has all these properties on the very right. On the first GUI we saw, the one that we're kind of trying to explain what it's doing. So going via that and getting the value, he's doing that via this variant function.
Sorry, those 3 lines, that one and the 2 follow it, have that UINT instead of where the PTR is, and then they have the PTR after. So what is that? What's different about that? What is that doing?
So you're talking about that one and this one?
Well, really that one, and then going down 2 rows. The one above it doesn't have that. Right? It doesn't have the UINT, comma 390 or 45.
Yeah, and here you're getting to the end of where I really know what this del call is doing. I understand this first part.
Yeah,
it's calling whatever, like get property value. It's most likely what's at the 10th place here on this one, on the element. And then he's passing in the element. And here, without looking at the definition of this information on wherever that is on MSDN, this would probably tell it 345, 45. That's value. to get the,
Sorry. Yeah, I do.
at that spot, that's value. And then he gets a pointer. That's what's returned. And apparently this variant, I have read about it before, but it's at the bottom here. So you pass in your own variable. That variable will be by ref. So something will be returned to it. And then on this line, you're setting the capacity of the variable to the size 8 times 2 or plus 2 times a pointer. So it's the size within that data structure of a variant. So the data type variant, it's building a variable that's able to hold a data type variant. Does that make sense? I'm not sure I'm explaining it well enough.
Yeah. But it's okay. I mean, it's advanced stuff, right? I mean, it's
and I'm maybe not getting it exactly, but it's still this one, and then a num put, where it's actually putting something into memory, and the same here. And then at the end, it ends there. That's the first part. It's building something within this expression. Then it's timing it with 0 plus the bitwise var. So this is over what I'm able to explain. I can't. I wouldn't know exactly how to explain that. But it is what this function does. It makes it able to hold a variant, which is a data type.
Okay.
So the data type of value is a variant.
Yeah, I'm getting it. Yeah.
Yeah. And those are those three.
Okay.
And this next line is, of course, one of these nice
multiple.
there at least, right? So I'll just do it like this. We can.
Right.
It's just a way of making it shorter and whatever. So what he's doing here is using the function string get on the name. That's the one up here. So he has a pointer to name. String get goes to that pointer and gets a UTF-16 value. So it gets a string in UTF-16 format and puts it into A.
Yeah.
And the next one is kind of doing the same. It's getting a number from the variant value here, and then using string get to get the string in the same format. So this is a pointer returned in a variant format that is then used numGet to get the number from that place. That's because the pointer is stored in that place in memory. And then string get is used to return the string from that memory location. So in B, you have value. In C, you now have L name, and in D, you have L value. It's good and great and all that.
Yeah, and just from, I know it's one of the things that it's like, why didn't they use those words, right, instead of A, B, C, D?
Yeah, again, totally. And here he's making some of these, I would say almost unnecessary short code stuff, just to make it harder to read almost. But
yeah,
that's of course not
Look
right.
what I can do. Sure, I know.
Yeah, but again,
he's like, what are the odds anyone but me is ever going to look at this? Okay, I'll make it advanced.
Yeah, and he understands it.
Right.
So again,
more power to him. Yeah.
Yeah, and I was unsure if there actually was a VIS function, but it's here. It's there. So there the function VIS is. It needs an object, and it needs a by ref text. And what it does is it iterates over the elements of the object. And if the value is equal to text. So it's searching. It's apparently searching. Does that make sense?
It's
BIS.
iterating over it. Yeah.
Yeah, it's iterating over the object. It's compared the object to the biref text.
Yeah.
And if those two are equal, it will return a false. And if it wasn't able to, so it's just looking, is this text value in the object? That's what it's looking for, right?
And if not, it comes back with a 1. Yeah.
If it
got to the end.
Yeah, exactly. So it's kind of a reverse lookup, right? It's a value checker. Here, this question mark there, that's a ternary operator, right? You have seen those before. So this is an expression. If A, okay, if A, then insert A into object, else 0. And here we just have it where it's making it even more advanced version of the same expression. So it's taking B and comparing it, bitwise compare or whatever you call those, with this, the value returned when looking for B in the object. So it's kind of checking if B is already added. I'm not sure why it's checking, but that's what it's doing. It's checking, does P have a value and has it not been added? Okay, it has not been added, then added. So that's what this one is doing. It's checking B, and it's checking if B has been added to the object. If that's false and that's false, or if that's true and that's true, that's a better way of putting it, it would insert B.
Yeah.
So B has value and it has not been added. Insert it. And that's the same for the other two. Okay. And here we have the same one, a del call that would use the virtual table. I'm not sure if virtual table is even the right term, but it's a table. Blah. It's using element, the one we got up here. We remember that one. Looking at the 21st place in for this one, current control type. Then it's passing in the element pointer, and then it's saying I need an unsigned integer, some size. I'm unsure what that mark there does. You can read on that in the documentation, and it's returned into the variable type. And the next line here is then checking if type is a specific type. Is the type 15,004? If it is, then use the next function, the one down here, get element whole. Apparently, if it is a specific type of control, you can use whatever this one down here does. You can create true condition, control L view, walker, get root element, compare elements. Stuff like that is something you can do on a 15,004 control type. Are we still okay with the stuff I'm saying?
I mean, I understand the stuff you're saying. I don't see where it's going, but I'm following what you're saying.
I'd say the stuff that where we are going currently is that we have already built element or item. Sorry, we've already built item. But if I'll just put these here. Oh, that wasn't the correct button. Interesting. So.
You want me to delete it?
Yeah, thank you. Yeah. So we'll again do like so. And this one is actually an if structure, right? But we'll keep the January operations here.
Yeah.
But it was just to kind of separate out what it's doing. So if that's the type, it will go to this function. It will pass element to it. That's the element from up here, right?
Yeah.
So that's the element from pointer that is then passed into get element whole. So here we have that. We have some static. Has it already been initialized apparently? If it has been initialized, then, so if that's true, okay, so maybe it can uninitialize it, because if it's static and it's automatically set to 1, this initialize would happen first always, right?
Mm.
So maybe it can be uninitialized, but who knows? Then it's getting the virtual table using the UIA com object, going to the 21st place, passing in the UIA com object, and getting a pointer to true condition, right? This create true condition.
Okay.
And here UI, so initialize has some kind of return value added to it. I wouldn't be able to tell you if whatever that del call actually returns, but if it fails, it's probably returning a 0. But, or no, that would, no, doesn't matter. But again, we're still calling whatever is retrieving or using whatever is at the virtual table's 14th place. Control view walker. Passing in the UIA com object and getting a pointer to this control view walker.
Right.
On the next one, we're getting the root element function in the root, and these tooltips that come below is actually quite disturbing in a bit, but here it's the same. Compare elements. It's actually returning the functionality of how to compare elements. And then it's releasing root because it only grabbed the root to actually get this one. Yeah. I don't know, but again, you'd need to read up on UIA and the function at the third one to compare elements, and see which parameters it actually needs. And apparently it needs the UIA as the dis, the pointer to the element that we're interested in, and a pointer to the root element. And the root element could be, if it's something in Word, it would probably be Word, right?
Or that Opus thing that we saw, or
yeah, exactly, Opus app, right? Whatever the root element is, it's probably not desktop. It's probably something within the process, right?
Yeah.
That would be returned and used there, and that would then make you able to compare elements. Then it's releasing root because it has no more need for it. Sorry. If same, then return. Okay, so what it's actually doing is it's, to me, without knowing, is probably comparing element to root. That's my guess, right?
Yeah.
It's actually checking if these element and root are the same.
Right.
Because then it would return blank. So E would actually be blank. And that would make this one here fail and then return a 0. Does that make sense, John?
Yeah, it does.
Yeah. Okay, so here we're there. then we're using the walker. And it actually, this del call apparently has a return value that's interesting because he's actually storing whatever it returns.
Yeah.
But it's using get parent element, so it's using the walker to walk the element and get that element's parent.
Yeah.
Here, what I'm unsure of is this control L view walker, if that always walks in a specific direction, because apparently it's returning the parent. Here it's get parent element. So the tree view walker has the method get parent element. So that's what we're actually returning in parent, not the parent element, but the function get parent element. Does that make sense? So they're calling get parent element, and here we should now have the parent element of element. It's back and forth, but yeah. Hopefully we're explaining it okay. If a parent actually was returned, then empty E, just make sure to clear it. E hasn't actually been used in this function yet. So it's interesting that he starts out by clearing E.
Right.
It shouldn't. To me, it shouldn't be needed. But
unless
again,
you come back again, right?
He's making the function local, right? By having global here, that would make the function local. I can't remember which way it is, but from what I'm seeing, E is not used anywhere else.
Right.
So when you get here, E should already be blank, just from the effect of being a new call.
Okay.
So unless this here, this block here, actually called itself, still it wouldn't. This would always be blank here.
All right. Anyway,
he's clearing it. That's fine.
Yeah.
No problem. And again, with him, the way he's using global and stuff like that, you could probably end up in a situation where E might have a value, right? So,
yeah.
Then he's using parent. So he's going from parent, the pointer to parent, looking at the sixth place where apparently find all is located. Then he's passing it a 2. Whatever a 2 is, we need to look at find all. But with most of these find things, this 2 would probably be the direction of looking up or down, or is it allowed to wrap over, blah, blah, blah. All of that, just like you would have in a normal find functionality search. And then he's passing the pointer to true condition. So again, this is probably like in Excel or Word, or all these variable things.
Yeah,
or a constant, exactly. So he got that true condition from up here. So he created a true condition. So a data value that is a true condition. And then he's passing that in here. And then he's passing, or he's getting a pointer of an array. So here we have a variable that now has a pointer value, but in memory, it's pointing to an array. So it's the beginning of whatever array structure is in memory. He's using that array here. In the third place of that array, whatever is there, apparently it's the length that's at that place. Again, you'd need to look at the documentation, right? Or in a header file or something else to determine all of these things. But he has done a good amount of work on it here. And he returns the length of said array. And Here he's looping over the length of the array. So length, loop, is going into the array at the 4th place, apparently on array, on a index. We already know how this works.
Yeah.
A index -1, that's a 0-based thing. It will start at 0 and then just build upon it. And it's putting whatever it finds into new element, because this one is calling the array 4th place is get element, right? So array 4th place has the method get element, and that element that it gets from this array, he puts in new element, or the pointer to it, he puts that in new element. And then on that new element, he uses the method at the 23rd place, which apparently is current name. Then he puts that pointer in name.
Mm-hmm.
Then he uses our good old function string get to get a value from a pointer in memory and puts whatever he found. He actually appends, that's correct, that into E. That's probably why he's also clearing E, just to make sure that E is cleared. Yeah. And then he releases the element, goes back up, goes down again, sees are there more elements on this name, on this element, right? So it's just a way of making sure that if it actually has more name attributes, right? Because it's looping all over the find all thing, right?
Mm-hmm.
So if it had more than one current name or whatever structure he's trying to make it work on here, he would build a name string. Then he releases it, then he loops over all of them, then he comes out here, he makes sure to release the array, he makes sure to release the parent, and then he returns the E. And E will now hold a plain old string, because that's what this converts it all to. So it will go into memory, getting all of these name strings, putting them into E, and passing back bullets.
Would there be any? Is it pulling a letter at a time? I don't understand why, when he's appending the stuff to E, he's not using anything to separate, what comes back. It's combining them all, right?
Yeah.
So is it each letter? That's what I don't understand.
I don't know what array holds. Apparently it's holding find all, and it's finding all of what? Choose, maybe. Do get what I'm getting at here?
Yeah.
This line here is the one, right? That is making the array.
It shoves right.
And it's using the find all without knowing what the find all actually returns or finds. He is telling it to find whatever 2 is.
Yeah.
Maybe not position 2, but whatever a call to find all 2. What's 2? Is that everything?
Oh.
Is that words? Is that...
Okay, it's like a constant kind of thing. Yeah.
Yeah.
It stands for something.
Yeah.
Well, it's find all, whatever that is. Yeah.
Yeah. We know it's finding all of 2s.
Right.
Whatever the value 2 actually means it's finding, and
you.
then putting it into array. So it might be all letters, or it might be all names, or it might be all text, whatever. But it's at least putting it into array. And we're looping over all of what it found. That could be all words or all letters. And just to make sure that it's returning all the text that it found, he's appending it to E instead of just saying E. because it might have more than one current name.
Mm-hmm.
Just a guess as to what he has done here. I'm not sure which parts of this are needed or not needed, but he's trying to make something that will always return some text to you. And that's probably why he called the function a screen reader and not a get button names, because he's actually not, he's finding all kinds of text or whatever names.
Right.
And building a string from that information and returning it. So it returns E with whatever string it was able to return from the whole. Then it's checking E. Has E been added to the item list? No, it has not. Then insert E or insert 0. Then it's releasing element. That's the element from up here, that one.
Right.
It has now been used in this function down here. Doesn't matter, but now it's been released. And then it returns the object item, the one that we started building up here.
Cool.
So what has been added to item? We have added A, which was the value. No, it was the current name. It was the value, it was the L name, it was the L value. Mm-hmm. And then if the type was this one, we have also added whatever this find all returned. So item up here. So here this item will now have whatever types of A, B, C, E, or whatever. And what he's doing here is he's checking, does it have at least one? Yeah. Does it have one entry?
Right.
Was one of all those checks actually successful? If not, return. So, and if it was, go here over the keys, over the values of item, and then add them to the edit control that we saw on the GUI. So that's what this is actually doing, right? Mm-hmm.
Pretty awesome, man.
Yeah.
I think that was a good. Let's go ahead and stop there on this one for now, and then hopefully, and it may not be for a couple of weeks, but hopefully we'll be able to take this a little further using some other things that we're learning.
Yeah.
Awesome. That was very cool. Yeah. Thanks for walking me through that.
Absolutely.
All right, ma'am. We'll see you soon.
Yeah. Bye.